Hello everyone, I'm Sudarshan Gopalakrishnan and I study EECS at UC Berkeley. I work in the DataX lab and I took the DataX course in fall 2018. In this video, I'll walk you through an introduction to web scraping. As you have learned, web scraping is a technique that you can use to gather data from the internet. In this demo, we will scrape through a demo website and illustrate some basic elements that you can extract. First, let's look at the sample website. It is a simple website which contains text in different header styles and font sizes, some text in a container, text in a list format, and text in a paragraph style as well. Now let's jump back into the code. We start off with calling the imports. Requests is used to query the website. BS4 represents Beautiful Soup, which is the Python package that helps with web scraping. And pandas is used for storing and cleaning the data. We start off with downloading the websites with request.get, and we store this data into source. When we print source, we see a response 200. This means that the website has been successfully downloaded. Some other status codes that you should be aware of are 404, which means that the website is not found, 403, which means the access to this website is forbidden, and 408, which means the request query to this website has timed out. When we print source.content, it gives you the HTML content of the website. As you can see, it is pretty hard to decipher. And we can also see that the type of this data is in bytes. When we pass this byte stream into Beautiful Soup and state the features to be HTML .parser, which is basically denoting that Beautiful Soup should look out for the HTML syntax/format. We use this process to create a Beautiful Soup object, and we store this in soup. We can test this by printing the type of soup, which is again a Beautiful Soup object. And when we print soup, it gives you the HTML website in a format that is a lot nicer and similar to what you see when you get the source of a web page. Before you continue with the remainder of the video, I would suggest using the links provided in the notebook to familiarize yourself with HTML tags and how HTML code and sites are structured, in the event you are new to this. Basically, HTML allows you to have classes and define IDs to certain part of the code so that you can attach design elements to them via CSS or refer to them in more complex programming situations, such as using JavaScript to build an app. Let's see this in action. When we print the content of the website, we see that h1 has a class set to be a header, and the text area associated with the first h3 tag has been ID'd as second. We can also extract different parts of the website through its HTML tags. For example, we call soup.title or soup.find and pass title to it in order to retrieve the title of the website. So let's demonstrate this in the code. In this case, soup.find should be a preferred method to do this since it's safer. Similarly, you can find text with the tag p by passing p to soup.find. Let's demonstrate it in the code again. If you want to find all elements associated with the tag, you can call the function findAll. In this case, we find all the elements which have the tag p associated with it. We see that the results are delivered to us in a list format, where it is a list of all p tags. Furthermore, you can also find content by class and by IDs by specifically saying class equals or find ID equals, and then passing the class or ID you're looking for when you're calling the find function. So in this case, we say that we want the class header, and we pass that to soup.find, and we get our header, which is simple data x site. And when we pass the ID second to soup.find, we get the text associated with the h3 tag, which was ID'd second. You can walk through the notebook to explore more functionalities of how to extract some of the other elements that exist in the website. So one special case you should consider is finding links. Links are stored in tags called ahref. In this case, you need to first find the A tag, and then you retrieve the href, where the link is actually stored. The section of the notebook, which starting from the cell that I've highlighted here, walks you through the techniques you can use to retrieve links. Let me just run through the code real quick. We print the A tag, and we look at the type of it. We see the ahref tag, where we see that the text associated with the link is London, and the actual link points you to a Wikipedia page. And we also see that the type of this A tag is a tag object. When we get the A tag and then call get and pass href to it, we get the actual link that this link tag object is pointing to. We can use the techniques that we demonstrated above to find all the links and extract details from there. And you can refer back to this notebook in order to see how this is done. As you're web scraping, please keep in mind that web scraping is not always a welcomed activity. So when you're scraping a website, please be sure to be mindful and nice, and make sure that you're not sending too many requests to a website. In reality, when you send too many web scraping requests to a smaller website, you might cause these websites to go down temporarily. And this creates a lot of trouble and rather a hostile environment for small startup founders and engineers. So please keep in mind of this caveat as you explore the world of web scraping. So the rest of the notebook explores some tips and tricks for web scraping, jumps into more advanced web scraping techniques, and discusses some infrastructure tools that you can use to bypass any limits that websites might place on a particular user for web scraping. So if you're interested in learning more about web scraping, please check out this notebook after this video. Thank you for watching.